Hey, this is Professor Roldan again with Chapter 12 in Explorations in Math. This unit will have many things that you're familiar with, but it will also contain things that you're not familiar with. So we're going to start with 12.1, we're going to jump to 12.3, and then we'll do 12.2 and 12.6 later. So let's get started with 12.1, which is mostly vocabulary, and we work through some of these in our classroom activities. So let's go ahead and start off with some of the basics here. First of all, we have, so what is statistics? Well, statistics is the art and science of gathering, analyzing, and making inferences from numerical information obtained in an experiment. Okay, so these definitions you can get straight from the textbook, which basically will start on page 725. Okay, so you can fill this out pretty much yourself, but I have most of these here for you. So you can we all actually have a class, an intro to statistics class that you can take. And then if you're much more interested, you can take it a step further and take mathematical statistics, which goes deeper into the topic. So you can actually, some colleges offer this as a major, bachelor's degree, master's degree, PhD as well. So, descriptive statistics versus inferential statistics. Descriptive is we are just describing the facts. So you collect the data, you organize it, and then you do the numerical analysis of the data. Okay, those are just the plain facts of the case of whatever you are studying. So that's descriptive. But then you must interpret that data. So this is called inferential statistics, where after you've done the analyzing and organizing, you make generalizations or predictions. Okay, and both of these types of statistics are very valuable in the real world. Okay. So, for example, you may have a math type person doing this who will feed the information to, let's say, a manager or a CEO, for example, and they will have to use that data to make a decision, basically, okay, or agree with the information or the conclusions that was given to the manager. All right, next we have population versus sample. So when you're doing an experiment, the population will consist of all the items or all people of interest. Okay? So for example, if we're going to make conclusions or generalizations or predictions about Southeastern students, for example, Southeastern students will be our population. Okay, and that population consists of all types of students, as first-year students, sophomore, juniors, seniors, bachelor's degree students, master's degree students, PhD students, and you have students of all races and from many, many different states and nationalities. So, and ages as well. So that will be our population. Now, sample is a subset of the population. That could be all males would be a subset, or all females would be a subset. or all freshmen could be a subset, or you could be just sampling those who are graduating, things like that. Okay, or certain majors. Now, you do want to consider unbiased samples versus biased samples. Now, unbiased sample is when you actually produce a sample that is a small replica of the entire population. Okay, so interviewing or surveying the entire population is not very cost effective. It's going to be expensive, takes a lot of time. So you want a small replica to represent the population, and that would be the unbiased sample. Okay? Now, unbiased sample would be basically, we're going to talk about doing random samples, systematic samples, cluster samples, stratified samples, convenience samples. So when you don't use these samples, some people who want to prove a point that's biased towards their position, they may not use these in the right way for their own advantage. So that would be a biased sample and would not be valid. Okay, so what are those 5 types of samples? The 5 types of samples that you need to be familiar with would be random samples, systematic, cluster, stratified, and convenience. Okay, so a random sample, okay, so that each item selected has an equal chance of being drawn. Okay, so an example would be, let's say you wanted to you are making a drawing for, let's say, a winning ticket or something like that. So let's say you have tickets in a bag, for example. Okay, and you randomly pick, you close your eyes or you're blindfolded and you pick a ticket from the bag. Okay, that would be random. Now, if you want to make that biased, so you don't have an equal chance, basically, some tickets could have a different feel to it, so you know which one you're picking. Or let's say you're not blindfolded and you are looking at the whatever you're grabbing. So that's not random. Okay, so that will be biased towards whatever intention that the person has. So to make it unbiased, you need to make it random. You can't see what's going on, and everybody has an equal chance. Okay, equal chance. Okay, no cheating. So that's a pretty good sample there. Then systematic sample. A systematic sample would be selecting a random starting point and then selecting every nth item in a population. Okay, so an example of that would be, let's say you, if you're inspecting burgers that are being made in a burger place, let's say McDonald's or something, and you pick basically, you just not grab, but let's say inspect every 10th burger to check if it was made correctly. Let's say for a new employee, or if it's an inspector who wants to just to check for quality assurance, things like that. So every 10th burger, you just counting, and that's pretty good type of sample. Okay, you're not just picking the best one. You're not looking and using some type of bias to pick the burger that would look the best or was made by the best worker for your own advantage. Okay, has to be random, has to be every 10th burger, has to be, and that's what you have to stick with. So another type of sample would be the cluster. And cluster is an area sample. This is mostly based on geography. Okay, so an example of that, let's say children in a large city are classified based on the neighborhood school that they attend. A random sample of 5 schools is selected. All the children from each selected school are included in the sample. So this would be cluster. Okay, so let's just say 5 schools chosen from a certain area. Of the city. Okay. Now stratified, this is more with comes from strata. Oops. So the keyword is strata, which will be basically things like gender, race, religion, income, things like that. Okay, so you're creating a sample from a certain strata, okay, that you're interested in. So an example of stratified sampling would be more like selecting, let's see, selecting students from each category: freshman, sophomore, junior, senior, for example. Okay. So when you divide the data into classifications like this, that's stratified. Okay. And then convenience, obtaining data that are easily and readily available. Okay, so if you wanted to do a survey, basically you stand outside of a class, or stand outside of a chapel and ask the first 20 students who walk out. That's basically super easy. You're standing there and you just pick the first 20 students coming out. Okay, it's super easy, it's convenient. So that's convenience sampling. Okay, so those are your 5 types of samples, and those are pretty unbiased, but in each of those, a person can actually just make it unbiased, just by not, or just trying to use this technique to fit their agenda. Okay, so you have to be careful on how the sample is taken. So a couple misuses of statistics. And when you hear a statistical statement, you can't just accept it as a blind fact. You do need to ask yourself a couple questions to determine if it's a fact, if it's reliable, and that is, what was the data unbiased? Okay, and was it a sufficient size? Was it a sufficient size? So if you ask, if a survey was done for 5 people, that I don't think is a big enough size to determine whether something is reliable and unbiased. Okay. So you need at least 30. 25, 30 is a good number. The more, the better. Okay, but it cannot be super small. Another question is, can the statistical statement be interpreted in more than one way? So if it's vague, then that's probably not something you should accept as fact. So an example would be this statement. 4 out of 5 dentists recommend sugarless gum. Well, that may tell you, wow, most dentists are recommending sugarless gum, so if I'm gonna chew gum, let me buy sugarless gum. Okay, so we don't really know the sample size. Okay, 4 to 5 dentists. What if it was only 5 dentists that they actually interviewed? Hopefully, it was hundreds and hundreds of dentists, but we don't know how many times the experiment was performed, and the advertisement doesn't really mention that maybe only 1 out of 100 dentists even recommend gum at all. So these statements like this you see on TV, you see them as you're walking in the store, and you just cannot accept every single statement as fact, as truth, just from initial. A lot of the companies are legally allowed to say things like this, because technically they're not lying, they're just not telling you the whole truth, and so gotta read the fine prints and get to the bottom of these statements. Okay, so especially if it's something really, really, really important to you, and you are, or if it's gonna require a major investment, or if a life-changing decision, things like that, definitely want to question statements like these so that you can make an informed decision. Okay, so please be careful of that. Now we're going to look at some charts where these decisions can be made rashly, but as a closer look, not paying attention to some of these graphs, you are going to come up with the wrong conclusion. Okay, so you want to watch out for misleading or even deceptive charts and graphs. So right here you can see these lines look very different. Okay. And so this is the original graph. And so what happens is, depending on what you want to show, you can change the y-axis, okay? So you can change the scale. So notice that the scale for the y-axis has changed. So it's this, over here it's at 11, okay? And over here, it's 50. So if you increase that scale, then this look like this looks very slow growth. Okay, so depending on what you want to point out, if you decrease the scale, then the slope is going to look very steep. Okay, so be careful on scale, okay, to see if they are exaggerating the claim or whatever it happens to be, okay? Another thing you can do is changing ratio of graph dimensions, okay? The ratio of graph dimensions. So here, again, here's the original, and if you do half the width, twice the height, of course, it's going to look, so if you notice, this is stretched out all the way over here, okay, compared to this. So what they did was they made this a lot shorter, made this a lot longer. And it kind of affected the slope as well, okay? Okay, so here's twice the width, half the height. So those are two different ways you can, that are used to manipulate the graph. So this is not to cause you to be skeptical of every single graph, but you do need to take a glance at the scale to see if they are using it to their advantage and basically affecting their bias, all right, towards a particular decision that they want you to make, or an opinion that they want you to come to according to these graphs. And the last thing I want to look at is bars and pie charts. So if you notice that both of these are the same data, it's identical data, and if you notice the scale, okay, this is the 12,000 here, all right, and it starts at 0. So if you notice, not a noticeable change. But if you come over here, you can see that this starts at 9100. Okay, so we call that truncating. When you chop out a big portion of your graph, you've just truncated it. Okay, so now that you've truncated it, this thing looks like it's very successful in whatever that happens to be. Okay, when it's actually not. Another one would be pie charts here. As you can see, here's the regular pie chart, and here's the misleading pie chart. So item C appears to be at least as large as item A. Okay. Are they the same? And if you look at the normal chart, no, they are not the same. Okay. So be careful with scale and the way things look, to make sure that you're not being duped by whoever's making these charts, graphs, just to prove their own bias. All right, so this is it for 12.1. Gives you the basics of numbers and statistics, sampling, and bias, unbiased, and then of course the misuses of statistics. Okay, so we don't want you to get the impression that statistics is used only for misleading or cheating the consumer, but most statistical reports are going to be accurate and useful, but just you need to be aware of these things as a informed and educated consumer. All right, we'll see you in the next video.